We're live. Okay, so today is last day of May. Awesome. 5, isn't that crazy? And then June's tomorrow. Okay, draw the 45, 45, 90 triangle. Okay, so I'm going to try and draw it nicely. We'll see how well I can do it, but I know 45, 45, no, they got to be equal, right? Half a square. Half a square, right? So the 45, 45, 90 triangle, right triangle, is really half a square. If I take a square and cut it in half, it does make a 45-degree angle, right? That makes sense. Take a square, cut it in half, it's got to be a 45-degree angle. And then I do know that these two sides must be equal because it's half a square. Well, no matter what, these two sides are equal, so let's just call them x and x. And I like x and x. We use x and x because it describes any number. I mean, give me a number. Give me a number. It could be any number. That's why it's x and x, right? It could be any number we want. Well, then instead of doing the Pythagorean theorem, which we could go, okay, x squared plus x squared equals c squared. We could do this, which is 2x squared equals c squared, which is the square root of 2x squared, which is x squared to 2. Okay, there's the proof, but I don't want to do this all the time. Takes more work. But Tava, you're right. Pythagorean theorem will work. But it's faster for me to know if it's a 45, 45, not 90, that this hypotenuse, just whatever these numbers are, times the square root of 2. It's just fast. That's all. It just saves us time. So if I take a look at example 1, I know if it's 45, it has to be 45 degrees here, right? 45, 45. So then I know if it's half square, if this is 8, then, well, this side also has to be 8, right? Half square. And then instead of going 8 squared plus 8 squared equals c squared, well, this is just going to be 8 times the square root of 2. And as a decimal, if you needed a decimal, we could. 8 times the square root of 2 is about 11.3, but I like 8 squared root of 2 better. It just looks nicer. It's not an ugly number, okay? Now, example 2, it's almost like they gave us the answer. We have to go from the answer and go back and find out what two sides are. I do know it's a square because the little dashes show me these two sides are equal, okay? So if these two sides are equal, then I know for sure it's half a square, which makes this a 45-degree and a 45-degree angle, okay? So in that case, it fits this here, except for 18 square root of 2. That means this side must be 18 and this side must be 18 from my special triangle. Does that make sense? That has to be 18, 18 for that to be 18 square root of 2. We're just working it backwards. Okay, now example 3 is a little different because right here should be some x square root of 2, but there's no square root of 2 in this at all. But I want to find x. Okay, right here should be some square root of 2, but it's not. So what I'm going to do to find x is I know that 12 is equal to some x squared root of 2, and if I could find out what the value of x is, I'd have x. So I'm just going to solve. So I took my 12 and I set it equal to x squared root of 2. All right, so let's solve for x. Well, I'm going to divide by the square root of 2. I divide by the square root of 2. And 12 divided by the square root of 2 is correct. That's the answer, but there's a better answer, okay? So you remember how we fix square roots, because we're not supposed to have square roots in the bottom. And you remember that? Can't have a square root in the bottom. But remember how we fix that?
Bring it to the top.
Yeah, we just bring it to the top. So I'm going to multiply by the square root of 2, square root of 2, and I wind up with 12 square root of 2 over 2. You know how I got the over 2? Square root of 4. So I'll put it over here. It's really 12 square root of 2 over the square root of 4, which is just 6 square roots of 2. So this side is 6 square roots of 2, and then the y, since it's half squared, is also the 6 square roots of 2. That one's a little bit harder, but it still follows the same rule. Okay, how am I doing?
Aren't x and y just 6?
They're not. because that's a 12. It's just the opposite. If that were a 12 square root of 2, yes, but it's not. It's just a 12. Okay, so if I look at this one, Teva, 18 square root of 2, right? If I look at this one, 8 square root of 2, right? I look at this, x square root of 2, but the problem is with this one, it's just 12. There is no square root of 2 with it, is there? And that makes it a problem because it should be a square root of 2, but it's not. So then I wound up with the square root of 2 to here and here, okay? Okay, let's turn the page. All right, now, the other one is my other special triangle. There's only two special right triangles. One's the 45, 45. That's the one we saw on the front page. And then there's this second one called the 30, 60, 90 triangle. And I like to draw it in two different ways because I don't want people to be confused. I can draw it this way, or I can draw it standing up. It's still the same triangle, but I'm going to draw it in two different ways, okay? 30, 60, 90. So if you were to draw a triangle and the angles were 30 degrees, 60 degrees, and 90 degrees, or in this case, draw a triangle and the angles were 60 degrees, 30 degrees, and 90 degrees, okay? Then the hypotenuse is always twice as long as the short side. The hypotenuse is always twice as long as the short side. But the longer leg from Pythagorean's theorem turns out to be whatever this number is times the square root of 3. And the same thing here. The longer leg is always whatever this number is times the square root of 3. What it does is it makes it fast. It's a special right triangle, so it makes my job easier. So if I take a look at example 4, I have a 30 degrees. If that's 30 degrees, then that's got to be 60 degrees. These two angles always add up to 90. You guys agree with that? They always have to add up to 90, right? They have to. And then, if that's the case, here's my hypotenuse. And it's always twice as long as this side. So this side's got to be 6, right? And then this side, the longer leg, is whatever the side is, 6 times the square root of 3. All right, example 5 is the same exact problem except for it's just standing up. It's not laying flat. So then I do know that if this is 60 degrees, this is going to have to be 30 because these two angles, acute angles, have to add up to 90. And here it is, 18. The 18 is twice as long as this side. So if this is 18, it's got to be 9, right? It's that easy. This side's got to be 9. And instead of doing Pythagorean's theorem, it's just faster. So, well, wait a minute. This longer leg is whatever this number is, 9 times the square root of 3. So it's going to be just 9 times the square root of 3. That's a bad looking 3. There you go. Okay, just using this formula right here. Okay, now, example 6. Find the area. Find the area of this equilateral triangle. Well, the area of a triangle is always going to be 1/2 the base times the height. All right, 1/2 base times height. Well, I don't know what the height is. That's what I have to find. So I know the height is right here. Since it's equilateral, I know it goes right through the middle at 90. I do know that, okay? That makes sense to me. If it's an equilateral, there's the height. But I don't know what the height is. Well, I go area. Okay, area is 1/2 times 10, right? But I don't know what the height is. Well, what I did is, in an equilateral triangle, it's a 60, 60, 60 degrees. You guys agree with that? Equilateral triangle, you got 180 degrees, divided by 3, 60, 60, 60. How's my reasoning? That makes sense? Okay, now, I still don't know the height, but what I've done is I've cut it in half, and what I have is a special right triangle. Right there, that triangle is the same triangle as that triangle there, okay? So what I have is my special right triangle. If this is 10. This is 5. And the longer leg is whatever this number is times the square root of 3. So this is going to be 5 times the square root of 3. Now I know the height. I know the height of this triangle is 5 times the square root of 3. All right, so let me finish my formula. Okay, so area. I got it. Area is equal to 1/2, because that's my formula, base, which is 10, times my height, which is 5 square root of 3. Now, you could give me this answer, 25 square roots of 3 centimeters squared. That's a great answer. Where to get half of 10? Half of 10. Half of 10 is 5. 5 times 5 is 25. You guys agree with that? Half of 10 is 5. 5 times 5 is 25. Or you can just give me a decimal. Decimal's okay also. You can say, well, gosh, Mr. Davis, what's, 1/2 times 10 times 5 times the square root of 3. Or you get an answer about 43.3, okay? Or approximately equal to 43.3. But I like this answer better. It's nicer. It's not as messy, okay? Sometimes you need this answer if you're trying to actually build something or make something. Okay, so that's all I have. What do you guys think? Pretty easy? Okay, and the homework shouldn't be too bad either. I'm not giving you a lot of homework, but you need to at least give it a try. Homework today is out of your journal, page 288, 1 through 10, all, okay? There we go. Okay, everybody should be able to do this. It's not difficult, okay?